Okay, we're in the EOC problems, the set which is 21 through 40. This is the second half of that video starting with 31, all right? Second half of the video starting, we're gonna do 31 through 40. And these go fairly quickly. These problems are not that bad. A lot of domain and range on these. Domain's x values, range is y values, okay? Which function has the fewest domain restrictions? When you see restrictions on the domain, you should think undefined. You should think 0 on the bottom of fractions, or negatives underneath radical signs, but we don't have any radical signs, so we don't have to worry about that. All right, this one, there's a restriction. X cannot be 1. Here, x cannot be -1, so those have the same same number of restrictions. Here, x cannot be +1 or -1, because either one will give you 0 on the bottom of a fraction because it's squared. All right, this is the only one. X can be everything. So it's asking for the fewest domain, so we're going to go with D on that one. X, there's no restrictions on x for this one. You can plug anything into that because it's squared. Squared plus 1 does not give us 0 on the bottom of a fraction. So we're going to go with D on that one, and there it is. There it is. All right. 32, inverse. We're doing a little bit of inverse. Just to remind you, inverse, we're just switching the x and the y, okay? But, of course, you gotta have a y in order to switch the x and the y, and the y is the same thing as that f of x. So now let's switch them. Now, let's get it in y equals form. B. There it is. I think the next one is also an inverse. It's just a little bit more complicated inverse. There's our y, same thing as f of x. So let's go ahead and switch them. We can either square that through, or we can take the square root of both sides. I'm going to go ahead and take the square root of both sides because I do see a square root in an answer over here. I don't know if that's the answer. I haven't memorized all 100 of these problems, but I'm going to take the square root of both sides just to get rid of that. Now we have the square root of x equals y plus 4. It's looking a lot simpler. And then, so I'll get it in y equals form, positive or negative x minus 4. I'm going to go with C on that one. There it is, C. All right, which graph represents the inverse? Inverse, I talked about this in a previous slide, or in a previous set. We didn't talk a lot, we talked a little bit about inverse, where you switch the x and the y and then you solve for y again. We did not talk so much about inverse, the graph of an inverse, okay? And this question, actually the next question I think asks, so the graph of an inverse rotates the whole thing, swivels the whole thing around this sort of invisible line, y equals x. So there's a line y equals x, so it just turns the whole thing around it like a mirror image, okay? So which graph represents the inverse of that? So we would be looking for, first of all, we need to know what that looks like. And obviously 2x passes through the origin and it goes up 2 over 2. So it looks like this, okay? Now, that imaginary line is just that perfectly 45-degree angle line, y equals x right here. So if we rotate that around it, it's going to end up looking like that. If we just swivel it around that y equals x line. That's what an inverse does, because we're switching the x and the y, all right? So we're looking for this line as our answer. Not that one, that's the original function. I would go with this one, B. There it is. All right. And yeah, I told you that this was coming up. Which statement about graphs and their inverse is true? They are symmetric. I'm just going to tell you this one. There's no work to be done, so you don't have to write calculator only. You can just write, Mr. Pierce told me that they are symmetric about y equals x, all right? Y equals x is this imaginary line, which, of course, you can graph it on your calculator if you want to, but it's a 45-degree angle line, y equals x. And inverses rotate or swivel around this. So for example, if we had a parabola like that, it would rotate around it and end up looking like this, because those are mirror images, if this is the mirror, and this would not be a function actually, all right? So a little bit of work there, a little bit of a lesson there within the lesson. Number 36, profits are equal to sales minus expenses E. Well, that makes sense. If you're in a business, sales minus expenses. You bring in $20,000 a month, your expenses are $12,000 a month, your profit was $8,000 that month. That makes sense. Business really is ultimately just adding and subtracting, although of course you can make it a lot more complicated than that. And when you analyze statistics on businesses, it becomes a lot more complicated than that. But if expenses are equal to travel plus materials, then which system models this situation? So expenses are travel plus materials. I like this one. Let's see if that one reappears. Yeah, travel plus materials. Those appear twice, so we can cross out C and D. And sales minus expenses. We're going to go with A on that one. Overall, these 80 problems that we're working on now are easier, I think, to a degree. They're a little easier than the EOC overall, all right? But it's still great practice. It's great practice. It reminds you of all of the skills, the radical skills, the rational expression skills, FOIL and working with polynomials and all that good stuff. All right, Tyrone. This is obviously a very old problem because TVs are like $300 now for a huge one, right? He wants to spend $10,000 on 2 televisions, all right? R and S. So we automatically know at most means it can be less than that, but it cannot be greater than that. So R plus S needs to be less than or equal to $10,000. That tells us one of the equations right there. R plus S, so this one and this one. We can cross off that one and that one because those give us R plus S is greater than $10,000, okay? Each television must cost at least $3,000. Television R has to be at least, which means greater than or equal to, twice as much as S. So I like C for this answer. There it is. 3 more. Meredith invests $50,000 in her new business. It costs the company $10 to produce each unit, which is sold for $15. Let's C represent the cost and R represent the revenue for the units. Which statement is true about the graphs? All that backstory was filler, fluff and stuffing. Doesn't mean anything to what it actually asks. Look at these 2 equations. There's a function right there. There's one of the equations. There's one of the equations. Both of these have positive slopes. How do you know that? How do you know that, Brody? Exactly. If this was in slope-intercept form, the slope is 10, that's a positive, and this slope is right there, it's 15, that's positive. So both slopes are positive. That's it. All that stuff about the problem was distraction, all right? There is a lot of distraction in the way they write some problems. Some. Which quadrant contains the solution to this system of inequalities? This is not one that I didn't solve this earlier because I knew that I knew that I could figure it out. The hardest part about this is putting it in slope-intercept form. Because even to use your calculator, you got to plug it into y equals. That's probably the hardest piece of this whole thing. So this first one turns into y is less than or equal to 2x minus 3, because I just added my 2x to both sides, okay? And that one looks like, there up to over, that one looks like this. And I'm shading. It's less than, okay? The other one is a little trickier. I got to subtract the x from both sides and then divide both sides by 3. So let's do that real quick. Greater than or equal to negative x minus 4. I'm going to divide everything by 3. It's a bit of a pain, but there we go. This is the same thing as negative 1/3 x minus 4/3. So there's my y-intercept. It's negative 1 1/3, so right here. And then down 1/3. So looks something like this, I think. Oh. That is so weird. I did not choose orange. I don't know what's up. All right, and it's greater than, so we're graphing up, up. So this one shades up. Where does the shading overlap? In the, I hope you remember your quadrants, first, second, third, fourth. The shading overlaps in our first and our fourth quadrants. 1 and 4, A. There it is. All right, last one in this set. What is the solution to this system of equations? We've got a system of equations right here. The solution, first of all, you could very easily and fairly quickly just plug x and y into both of those and see what you get. You could do that. Or we can add them, we can actually solve them the way we're supposed to, which is a bit of a pain. We gotta do a few things here. So I'm gonna use elimination. I'm gonna add these two up. If I multiply this one, top one by 3, my y's will cancel. Normally I should kick my numbers over, but it'll work like this. Trust me. 9x minus 3y plus 15 equals 0. Now I'm going to add them. 11x, 3y's cancel, plus 11 equals 0, right? So yeah, 0 plus 0. Pull that over, x will be negative 1. So it's one of these. I just got to plug x in to find out which one. So I'll plug it into the bottom one. Negative 2 plus 3y minus 4 equals 0. That's a negative 6. I'm going to add it to both sides. It's going to be 6 over here. Y would be 2. So I'm going to go with B on that one. Notice how I am skipping some steps every now and then. All right, as long as you can keep everything straight in your head, just don't skip too much. Okay. If the problem says there's a rectangle, start drawing a rectangle. If the problem says it's a square or a circle, start drawing that thing. All right? All right, great. I'll see you on the next set.